Good evening, friends. Welcome back to another session on supply chain analytics. Let me share my screen. Okay, today we will be discussing on supervised learning technique, and in supervised learning technique, we will be discussing on ANN, artificial neural network, and how ANN algorithm, that is machine learning algorithm, can be applied on supply chain analytics. Okay. Your artificial neural network or neural networks are basically your computational algorithms. Okay. It is intended to simulate the behavior. Okay. The human behavior basically. Okay. And here we will try to understand the biological analogy of the neurons at a high level. Okay. And here the arc is associated with the weights. A neural network is a machine learning algorithm, okay, based on the human neurons. Okay. And we know that for a fact that the human brain consists of millions and millions of neurons. Okay. And it sends signals, some kind of a signal, and these neurons get connected. Okay. And here in artificial neural network, the information is processed at a technique. Okay. In this way, the in such a way that human brain is processing the information. And in artificial neural network, the the application also happens at a rapid level. Okay. In data mining, these factors are used. For examples, you have certain industries applying ANN, artificial neural network. Okay, like your forensic department, medical department, etc. Okay, it can also be used for your data classification. Okay, if you're dealing with large data. So when you talk about neural network, there are three stages to it. Okay, primarily one is the input layer. Okay, in input layer, the activity of the unit the input unit represents the raw data. Okay, that can be put into networks. And then you have the hidden stage, hidden layer. Okay, you want to look at the hidden factor, like your weights. Okay, the weights on the connections. Okay, and the connections between the input and hidden units. Okay, there is also called as output layer. Okay, and here the hidden hidden layer and output layer, what we can see is the dependency is there on the behavior of hidden layer based on the output. I mean, if you look at the output output layer's result is depending upon the weights on the hidden layer. Okay, so, and if you were to look at the structure of a neural network, and this structure of a neural network is called as topography or architecture. Okay, it has got number of layers. Okay, and one of these layers is input layer and output layers. Okay, and there could be one output unit. It could be a linear or logistic. Okay, and by adding one or more layers between the input and output layers, okay, the predictive analogy, the predictive assessment of the neural network increases, the power increases. Okay, and then this will avoid overfitting. Okay, even if the hidden layer is present or not, the outer layer can have multiple units. Your artificial neural network can perform extremely well on your linear and non-linear data. Okay, because any machine learning has some kind of a representative instances. Okay, and it is trying to connect the effectiveness of the software through the neural networks. Okay, it does not, your neural network is, it is a analyzed data already. Okay, any kind of reprogramming is not required. Okay, so we as users have to feed in the data and we train it. Okay. that is in between your input and output. Okay. Right. So the artificial neural network takes in the inputs and does a computation, and it does the weighted sum of the inputs, which includes the bias as well. Okay. And the capacity of performing, like, I mean, processing has also, like, it can go up to more than one task simultaneous. Okay. So artificial neural network is considered to be the emerging technology, okay, which can be put forward. Okay. And there is a research and development going on the biological human tissue, right? And there is so much progress on the AI part of the research, right? And these principles and AI techniques are to be successfully applied, and then you cannot be comparing these two techniques or AI techniques to that of the other. Okay, yes, there are few scenarios where these two models or case can be combined in a systematic way again. Okay, it is like a your neural networks can be modified in such a way based on the external environment, and it can train and it can decide for itself. That means when a part of the information is input, and you have to internally feed in the parameters, okay, say the weighting coefficient, and eventually it will produce the consistent output, right? After this self learning, we'll have to look at the effects, like they might have the longer sensitivity. Okay, sensitivity parameters should also be considered. Right? Longer sensitivity as well as stronger tolerance rate. Right? And they are applied on a larger variety or larger scale fields. And supply chain network or supply chain management is one of the networking companies or the sectors, we can say. In this, we can be applying at a intermediate level, okay, where you have a finished product and it can look at a multi-level system. Okay. Okay, it can be looked at a planning stage, controlling stage, as well as distribution, retail into retail sectors, right? It all depends upon the characteristics of the area. And of course, customer satisfaction also. Okay, customer satisfaction can be improved. The overall operating style can be the the fashion which the operations happen can be improved, right? The optimization, when it comes to neural network, the optimization part is a neural network is a powerful computing technology, okay, technique basically. Okay, it will optimize, it will solve the optimization problems. Okay, as well as the, for example, a selection of transportation or transportation route or logistic transportation route, right? That way the uncertainties can be avoided in the operation. Forecasting is possible. Okay, and internal decision making or decision making at a area or a department. Okay, for example, when a staff or a head of the department is making some kind of a decision, right? There are basically two issues that he or she will be facing. Okay, one, the information could be too large, right? Or the other information could be incomplete. right? In a way, we talked about how this intelligent system or artificial neural network system is related to the human brain, how it is mirroring the behavior, okay, and starts starts to think like a human brain, okay. can it be can it be more decisive? Can it be more creative? Right? So because of neural network unique potential, the in supply chain management, we can apply these techniques. Okay. Or like the customer satisfaction, is the customer satisfied once, for example, we've been talking about a car manufacturing unit, right? If the customer has purchased a product, a car, and he is a customer until he is owning that particular car, and if he is returning as a customer, if he is a returning customer for let's say he is going for a add-on service like a annual maintenance, or will that help in retaining the customer? Okay, will we be able to analyze on the customer churn rate, right? Okay, based on what what is the decision making behind this, okay, is what we will be looking at. Right? And of course, forecasting, right? There are few uncertainties. Okay, whenever there is inaccuracy in forecasting, right? High volatile, high volatile rates, or you can say if there is a fluctuation in the market, or competitors competitors product launch, or like or a market collapse. Yes, these are few uncertainties we can talk about. But these can be handled, these uncertainties like forecasting can be handled by a statistical way, right? And when we talk about fluctuations in supply chain management, they are focusing on the demand of the product, demand in the market, okay, and that should be the priority when it comes to customers. So we also get to see about the back propagation network, or the neural network in the industry, like your sales. These are a few departments like sales. You have after sales service, the annual maintenance, right? Or the returning customer. Returning customer. So let us look at the model. Let me upload the data. Okay. So here I have my data. Just give me a minute. Just a minute, friends. So here I have, I should be doing data pre-processing. Okay. For all the models, basically. Just a minute. I'm just restarting the kernel to avoid any kind of glitch. So at certain times, you might get stuck with the output where your console will hang, especially like if you are using a standalone application. Okay. So here I have my data set. Uploaded. Okay. These are few libraries I'm importing. I'm importing NumPy. I'm saying import NumPy as NP. Okay. I'm saying from keras.models import sequential. Okay. Dense. I'm also importing dense as well as np underscore utils. If I have to look at the data, I pass the value. I say read underscore cv. Same data I will be looking at. Make sure to import your libraries. Okay, you can also use the cloud-based interfaces. If any of the libraries do not get installed, you can still use the web-based interface. See, it will not allow the default backward slashes. You'll have to replace them with the forward slash. Or you can use double backslash. Okay, and then you want to separate the data into two. Okay, and by that we can convert your integer data into float data. I say x underscore train. Here I am converting these values, integers into float data. Here you are also doing normalization and one hot encoding and label encoding as well. Okay, even if you do label encoding, you can still go ahead with one hot encoding. Okay, now I want to look at the shape. I say number of classes Here you're initializing the model. You're saying model is equal to sequential. Okay, we have imported a sequential library, right? Okay, so here, it keeps running. Okay, just give it a time, some time. Okay, and here you are evaluating the model on test data. And you verify if the model is fitting on trained data. Okay, and you train and test data on the entire data. If you are repeating the train and test, you'll have to do it on the entire data. Okay, and you keep repeating that. Okay, and then you evaluate the accuracy on the train data. Okay, you say eval underscore train. Okay, model evaluation. Okay, you normalize anything that is falling under 0 and 1. Okay, and you normalize by dividing the entire data. Okay, Now you are defining a function, okay, and which you want to return the model. Okay, you said DEF, okay, and then you are initializing the model. And if you look at the train data and test data, we can also look at that. If you have already trained and tested it, you have a train data and test data. So here I have it. I said train underscore. Basically, this is my data. Right? This is how my data looks. And you can also go through the documentation. You can use the help function to go through the documentation. Similarly, I can also look at the test data I have. This would be the test data. Okay. And we fit the model on the train data. You say model dot fit. Okay, x equal to x underscore train. Similarly, we evaluate the model on test data for the accuracy. All right. Friends, we will stop our discussion here for the day, and we will continue in our next session.
Hello. Hello. Hello.